Right, so moving on to our next example, exercise 5.5, number 3. Determine the points of intersection of the parabolas y squared is equal to 3x and x squared is equal to 3y. So that is the first thing. Then calculate the volume of the solid generated. Obviously we have to sketch these graphs, so let's do that. Okay, now for 3a, we have y squared is equal to 3x. So y squared is equal to 3x. So we have x is equal to a y squared, where a is a positive number. And the next graph there, let's sketch this graph here first. Right, for a more detailed explanation of x is equal to a y squared, you can refer to my video on calculating area, if I'm not mistaken, or it was area. Right, so we are explaining to you the difference in the parabolas. The parabola and you have the inverse of a parabola. Or basically, here you got x is equal to a y squared. In the other examples, we got y is equal to the square root of x. But anyway, if x is equal to a y squared and the coefficient of x of y squared, is positive, then your graph is going to be facing or pointing to the right. X can only be positive. Right, so that is x is equal to a y squared. Now, also, x squared is equal to 3y. Okay. So x squared is equal to 3y is in the form y is equal to a x squared. Right, so now a being obviously, if I make y the subject of the formula, y is going to be x squared divided by 3, so your a will be 1 over 3. Right, but what we're focusing on is if this number is positive or negative, and clearly my a is greater than 0, it's positive, so your graph is pointing up, it's a happy face. So now we sketch the graphs, and clearly we can see there are 2 points of intersection, one here and one there. Okay, so here is one point, and here is the second point. We know from our standard form for ay squared and ax squared, the turning points are at the origin. So that's my 0, 0. And we need to find this point. So now for points of intersection, we're going to solve simultaneously. Points of intersection, solve simultaneous equation. So we have y squared is equal to 3x and x squared is equal to 3y. Okay, so now you either take one equation, substitute into the other. Right, so let me go for y is equal to x squared over 3. So I'm making y the subject of the formula. Y is x squared over 3. So I have y squared is equal to 3x here. That's what I have. Y squared is equal to 3x. But what is y now? Y is x squared over 3. So I'm replacing y with x squared over 3. Now, this is within brackets, it's all squared, so we need to square the numerator and square the denominator. So when I square the left-hand side, I'm going to get x to the power 4 and 3 squared is 9. Is equal to 3x. Right, so that is a result of squaring the numerator, square the denominator. Now, if I multiply by 9 on both sides, I will have x to the power 4 is equal to 3x times 9, which is 27x. Now, I have x on both sides. Do not divide by x. You must make the equation equal to 0. So therefore, x to the power 4 minus 27x is equal to 0. Solve for x. Now, you factorize. X is common here. So you take out a common factor of x. What am I left with? I'm left with x to the power 3 minus 27. So now, x is equal to 0, or x cubed minus 27 is equal to 0. So x cubed is equal to 27. That means x is going to equal to the cube root of 27, which is 3. Alright, so now what does that mean? It means that the x value here is 3. The x value here is 0. Right, we know that we need to find the corresponding y values. So, what we will do is substitute into any one of the original equations. Y is equal to x squared over 3. So, let's substitute into this equation. If I take x is equal to 0, substitute here. 0 squared is 0, divide by 3. So, I know that y is equal to 0. And then, let's call this one x1, y1. Okay, your point of intersection here, when x is equal to 3, what is the corresponding y value? 3 squared is 9. 9 divided by 3 is 3. So y is also equal to 3. Alright, so those were the points of intersection. Now we need to work out the volume. Right, so those were the points of intersection. Now the volume. Okay, so 3a so we call this, yeah, that is 3a, and we sketch the graph is 3b. Rotates about the x-axis. So in N5, if the question states rotates about the x-axis, you need to use this representative rectangle. Okay, if the question states rotates about the y-axis, then you will use delta y. Okay. Why? What is the reason for that? Because we are using the disk method only in N5, and your rectangle must be perpendicular to the reference axis. Okay. So you use delta x. And what do we know? That delta x is perpendicular to the x-axis. Okay, perpendicular, there's your x-axis here. And it forms a perpendicular situation. It intersects at 90 degrees. Right, so now, let's do it here. So we got our graph. There's your parabola, that's one parabola there, that's the next one there. So I'm just doing a rough sketch. So you must use a perpendicular representative rectangle. Okay. So that is what we're doing for this question. Now, let's call the top y1 and the bottom y2. So it's volume of the top graph minus volume of the bottom graph. So what do we know now? Okay. Right, so you are rotating about the x-axis So you're going around there. Let's see what will happen here. So when you're rotating about the x-axis, remember there's your x-axis. You're going around the x-axis. So your radius in terms of y. Right, so when you're going around the x-axis, you're going up and down. So your radius is measured in terms of y. So the top radius is y1, the bottom radius is y2. So what do we know? Volume is equal to pi r squared h. Remember, we are using the disk method only. Right, we are using the disk method. So the formula for the disk method is area of base times height. So that means delta V x is equal to the volume of the top graph minus the volume of the bottom graph. Okay, that is the disk method. Volume of the top graph minus volume of the bottom graph. So what is the volume of the top graph? Your top is y1, so it's going to be pi y1 squared minus y2 squared times delta. So I'm doing it in one step. Okay, so you know it's going to be top minus bottom. When you factorize it, this is what you get. There's your top radius minus the bottom. Right, so now total volume. We're integrating from a to b. That's my y1 squared minus y2 squared delta x. Let's substitute. Now, what are we substituting? We are integrating with respect to x. That means we are interested in the x values at the beginning. Here's the beginning, here's the end. The x value at the beginning is 0, at the end is 3. So that's going to be 3 and 0. Now y1 squared. Let's go back to our diagram. Okay, so there's your y1, there's your y2. So there's your graph here. So this graph is x is equal to, sorry, y squared is equal to 3x. 3x is equal to y squared is your top graph. Let's call that y1. And this one is, x squared is equal to 3y. So this is x squared equal to 3y. And this is the bottom graph. So that is the bottom and this is the top. Now, what did we call? This is y1 and this is y2. Now, y1 squared. Now, that is y1 squared is equal to 3x. So, therefore, we do not need to go and square. It's already squared. And can you see that y1 squared is equal to 3x? So, there's my 3x minus y2. What is y2? y2 is the equation of this parameter, but it's not squared. So y2 is equal to x squared over 3. So this is going to be x squared over 3, but it has to be squared. Now I just need to simplify first and then integrate and substitute. There will be 3x minus x to the power 2 times 2 there, which is 4, and 3 squared is 9. Alright, so remember, a power raised to a higher power, multiply the exponents. Now we can integrate and substitute. Integrate 3x, so that will be the power 4. 4 plus 1 will be 5 over 5 times 9, which is 45. So now let's substitute our values and let's see what we get. Alright, so that's 3 over 2 x squared minus 1 over 45 x to the power 5. Substituting 3, I get 8,1 or 81 over 10 minus, well, if you substitute 0 here, you can see it will be 0. So basically it's 8,1 pi. 8,1 pi, which is equal to 25,447 units to the power 3. So that is 25,447 units to the power 3. Right, so that's 25,447 units to the power 3. Now we will deal with the y-axis. Right, so we're done with the x-axis. Now let's deal with the y-axis. So now remember, if the question states for volume, not talking about area, for volume. If the question states rotates about the y-axis, then you use the representative rectangle that has a breadth of delta y or a height of delta y. That's what you're going to do. So you know if you do this, you will call this x2, x1. So that's exactly what I'm going to do here. So that's going to be, here's my representative rectangle. So here, this is x2, and then is x1. Now, remember, delta y, and this is the y-axis. Here's your y-axis. Here's your y-axis. So, it is perpendicular to the y-axis. And so if you draw your representative rectangle from here all the way here, it is perpendicular to the y-axis. So therefore, this method. You must write this down every single time, because what you're doing here will be also used in N6. In N6 we do both methods. Okay. So now what is this method? You know volume is equal to pi r squared h. So now it's going to be volume of the graph on the right minus volume of the graph on the left. So we're going to go delta v y is going to equal to pi, and you got your delta y. Right, so you know that this is obviously delta y. So what you're doing is the graph on the right, subtract the graph on the left. So what's on the right is x2, what's on the left is x1. Here's it on the right and left. So we're going x2 squared minus x1 squared. Now, total volume. Integrate, that's d and c. That's going to be x2 squared minus x1 squared dy. Once you put your integration in, then we're integrating with respect to y. So your d and c is 3 and 0. So dy means y values, that means the upper and the lower. So the lowest point is 0, the highest point of the area is 3. You can see that. x2. Now let's go back. We call this one y1, so that's x1. So if this is y2, this is x2, because x2 is here. Okay, I call this one x2, yes, and this one is x1. So x2 is here. So x2 squared. x2 squared. x2 is already squared. So x2 squared is 3y minus x1. Now this is y1, this is x1. 3x is equal to y1 squared. So this is your x1. Now x1 is the same as y squared over 3. So this is y squared over 3, but it's all squared here. Because this is not squared. But the formula requires you to square it, simplify, and then integrate. That's going to be pi. So we did not integrate yet. That is 3, 0. So I got 3y minus y to the power 4 all over 3 squared, which is 9 dy. And now we can integrate with respect to y. That is going to be 3y squared over 2 minus y to the power 5, and 9 times 5 is 45. And substituting 3 and 0. If I'm not mistaken, this looks like it's what we had for the x-axis. So I got 3 over 2 minus 1 over 45. Let's see. 3 over 2 minus 1 over 45. Now we get the same answer. Same thing. So that's 8, 1. Which was equal to times pi 25, 4, 4, 6, 9, which is equal to 25, 4, 4, 7 units to the power 3. And that was number 3. Our next example, for A, sketch the area that the line x is equal to minus 5 cuts off a branch of the central hyperbola x squared over 16 minus y squared over 9 is equal to 1, and then calculate the volume. So, the central hyperbola. Okay, so your central hyperbola how do you know it's a central hyperbola? You see a negative in between x squared and y squared. Then, if you see this negative sign, then you know you're going to have one branch on the right and another branch on the left. That is your central hyperbola. Just because you see that negative sign. So what you need to do is, you need to work out the x-intercepts of these terms. There are asymptotes, we don't have to worry about that for now. The main thing is work out these x-intercepts. So if I want to work out the x-intercepts here, let y equal to 0. So if I replace y with 0, then I have x squared over 16 is equal to 1. So x squared is equal to 1 times 16, which is 16. So that means x is equal to plus or minus the square root of 16. So that means x is equal to 4, or x is equal to minus 4. Now, what else do we need here? Sketch the area that the line x is equal to minus 5. So there's minus 4. Minus 5 should be somewhere around here. So here is x equals to minus 5. So that's x is equal to minus 5, and this is x squared over 16 minus y squared over 9 is equal to 1. Now, we have the graph. We can identify the area. This is the area that's being described here. Now, determine the volume of the solid obtained when this area rotates about the y-axis. So, if it's a y-axis, this is n5 level. Simple, all you do is draw your representative rectangle there, which is delta y. So you know, if you have delta y, then let's call this x1, let's call it x2. Right, now, a volume, what do we know now? That delta y, and here's the y-axis. It is perpendicular to the y-axis. So you can see that. This means perpendicular. Right, so if it's perpendicular, I told you you must always remember that you are using the disk method because it's the only method that you are using at the moment. So we're going to go delta V y. Okay, remember your radius is measured in terms of x. So you need to write down the formula, substitute, and integrate. Right, so clearly we can see obviously there's two graphs, so it's going to be pi. Graph on the right is x2 squared, x1 squared times delta y. Right, so now total volume, we're integrating, that is delta y, so that's my d and c, x2 squared, x1 squared. What's your d and c? What is your d and c? Now, what we do is, we go to the height, we are dealing with delta y, so we need to know what is the y value at this point here. What is the y value at that point? What do we know about that point? We know that x is equal to minus 4. Sorry, not minus 4, x is equal to minus 5. Minus 5. But that is not what we require. We want the y value at the point. So in order to find the y value, I will substitute the x value. So we have an x value here of minus 5 into this equation, and we can work out the y value. So if I go x squared over 16 minus y squared over 9 is equal to 1. I know that x is equal to minus 5. So that's going to be minus 5 squared over 16 minus y squared over 9 is equal to 1. So minus 5 squared is a positive 25. So 25 over 16 minus 1 is equal to y squared over 9. So 25 minus 16 is going to give me 9 over 16 is equal to y squared over 9. So now I can work this out. 9 times 9 is 81 over 16 is equal to y squared. So that means if I find the square root of 81, that's going to be 9 over 4. So that's going to be a 9 over 4 and minus 9 over 4. So we know that this will be a positive 9 over 4. This will be a negative 9. How am I getting it? The square root of 81 is 9. The square root of 16 is 4. What is x2 squared? Where is x2? x2 squared is the central hyperbola. So x2 squared, let's make x2 squared the subject of the formula. So So I've got x squared over 16 is equal to 1 plus y squared over 9. That's going to be 9 plus y squared over 9. So x squared is going to equal to 16 over 9, and that is 9 plus y squared. So there's my 16 over 9, and that is 9 plus y squared. Okay, so that is my x2 squared. x2 squared, we are not finding the square root there. x1, what is x1? x1 is this line here. x1 is equal to minus 5. So that's going to be minus 5 squared dy. Right. So now that's my pi. 16 over 9. I can integrate 9, so that will be 9y. Integrate y squared, so that will be y to the power 3 over 3. Minus 5 squared is 25, so that's going to be 25y. Substituting 9 over 4 and minus 9 over 4. Let's see what we get. Right, so you need to take out your calculator and check. Also, you must be able to do this on the calculator quickly. Right, so let's substitute 9 over 4. I get minus 13, comma 5. Calculate, substitute minus 9 over 4. And I get minus 13, comma 5. So I'm getting minus 26. Minus 26, so it's minus 27. So that's minus 27. That's because I'm getting the negative because I took the right minus left. If I had taken left minus right, then I will get the positive. But basically, the answer here is 27 units to the power 3, and it's lying on the negative side, but the negative just indicates because we took left minus right, right minus left instead of left minus right. So 27 is, sorry, mistake here. That's not 27. Remember, it's that times pi. That's 27 pi, which is equal to 84,823 units to the power 3. Right, so if you're getting a negative, it just means that you subtracted it the other way. It doesn't really matter because the answer is always absolute value of what you have there. It means it will be positive. Double check your values.